All right, so here I'm going to show how to connect the outputs of your analysis, the figures, tables, numbers, to your writing in Overleaf. Here's our Overleaf project. We can see we have some figures, we have a table. Let's assume that these were uploaded manually, and basically this is the problem that we're going to solve. If we want to go and update our analysis, we then need to manually upload the figures. So the first thing we need to do is create our analytics project. In this case, I don't have one yet. I'm going to go to calkit.io and create one from an analytics template. Going to log in, authorize Calkit. I'm going to install the Calkit GitHub app for all my repositories. I'm going to create a new project from the example analytics template. If you already have something in GitHub, you can just paste the URL in here and use no template. Call this my analysis. So Calkit is copying the template and creating a repository in GitHub for us. Our analysis project has a pretty simple pipeline. We can see this on the pipeline page. It's got a single stage that runs a Jupyter notebook. It has an input data set. The example uses the Palmer Penguins data set, and it creates some outputs here, figures, tables, and some results that it saves as JSON. You can take a look at the figures. No publications, one notebook. So the next thing we're going to do is we're going to import and link the Overleaf project into Calkit. So we can click on this quick action link here, import and link. We're just going to need the URL of our Overleaf project. We need to put in an Overleaf token here. So if you go to your Overleaf account, go to account settings, there's a project synchronization section. And then there's this Git integration section. We're going to create a Git authentication token here and then just paste it in to Calkit. You can change where the Overleaf project gets imported into. The default is a subdirectory called paper, and you can choose if it's a journal article or conference paper, whatever. In this case, we'll just go with the default. A bunch of other options here that you can fill out if you want, but you don't necessarily need to. Okay, so we imported our Overleaf project, and this is now going to be in our publications. We're going to see this message because the PDF has not been built yet. That's expected. We can try syncing from Overleaf. No changes have been made. That makes sense. We can go into the Overleaf project, and we can do a little writing here. Save it, come back, sync, and we see that the change has been pulled in to the Calkit project. Next thing we're going to do is open the project in GitHub code spaces. And what this is going to allow us to do is work in the browser on both the analysis and the writing at the same time. So we'll click this quick action link, open in GitHub code space. We're going to have some options. You can choose if you want to use a larger machine or what region of the world you're in. I'm going to create a 4-core machine just because we are going to be running that notebook. So what's happening now is GitHub is building our code space to the Calkit dev container specification. The nice thing about this is that we'll be able to have this environment to work in the browser, similar to Overleaf, but we can also take this and run the same dev container locally in VS Code. So really you can work offline if you want to on your analysis and your writing in the same tool. This is going to take about 10 minutes to finish building the code space. After that's done, you don't have to do it again. Take a break, go get some coffee. All right, so our code space is done building. It actually only took 5 minutes. So if you haven't used VS Code before, it's basically like a text editor with a bunch of tools built into it to make it easier to write code, but also to do analysis in things like Jupyter notebooks. It also has built-in Copilot integration, so if you want to use AI, this will allow you to do agent-based modifications of your code, of your writing. You can ask questions. We are not going to do anything with AI in this tutorial, but it's there if you need it. So our goal here is to connect the outputs of our analysis with the writing. In this case, we see we have our paper folder. This was linked to Overleaf, and in the Calkit YAML file, we have our environments, we have the pipeline. Now it has 2 stages, a stage to run the notebook to do the analysis, and then we now have a stage to build the paper. We can go ahead and run this pipeline with Calkit run, And so this is going to execute the notebook for us. All the environment setup for any of the stages is done automatically by Calkit, so you don't really need to think about, do I need to install these certain Python packages, or do I need to install LaTeX even? This is all just done behind the scenes. So say one of your collaborators also wants to run this, they don't have to go through all the environment setup steps. Or if you want to do this on a different computer, same thing. Then we'll see we have the PDF of our paper. It should look exactly like it does up on Overleaf. You'll notice we have a bunch of orange and green in this file tree over here. And so we have new files, we have modified files. These were all created by the first time we ran the pipeline. And if everything looks good, we can just simply save the project and create a message in the history so we know when and why these files were created. So to do that, we'll just use the Calkit save command. So save, and then -A will mean save all, so save our entire project, and -M will mean we're going to put in a message for what this revision means. So we'll just say run pipeline for the first time. And then we'll see all of the orange and green in the sidebar is gone. Everything is saved. We have no untracked changes now. We can go back to our project on Calkit, take a look at the publications page again, and we'll see we now have the PDF of our publication. We can sync it with Overleaf again. If we go back to the code space and then go in and edit our paper, let's add some text. Here's some writing from code space, and we can again see that we have some modified files in the sidebar. If you want to get a similar experience as Overleaf, you can click this View LaTeX PDF file, and you can view the PDF right next to it. It's going to automatically rebuild, and we see we have that showing up in our PDF. If we take a look at Calkit status, we can sort of see the overall status of the project. Does the code or text have any changes in it? Do the data files have any changes in them? In this case, the PDF is considered a data file since it's not plain text. And we can see the status of the pipeline showing us that the build paper stage is out of date. It needs to be run. So we could just go ahead and run our pipeline and save it all in one step. Calkit run and then --save. And what's going to happen here is that if the pipeline successfully runs, it's going to automatically save it for us. So it's going to save a revision in the history using Git, and it's going to push those changes up to both GitHub and Calkit.io. So we have everything backed up in the cloud. So we see the pipeline ran successfully. If we go to Calkit.io again, refresh, and see we have the writing from our code spaces there. Now, we haven't yet synced to Overleaf. If we go to Overleaf, we see that there isn't any code space writing here. So we need to do a sync. We can do that with Calkit Overleaf sync, and that was successful. Go back to our Overleaf project, and we see the writing from the code space is there. So basically we can work in either place, and anyone on our team can work in either place. But we still haven't actually connected the outputs of the analysis to the writing. So let's go back into calkit.yaml. So if we go back and look in our pipeline, currently our paper is building based on files in the paper folder. But when we run our analysis in the notebook, it's creating figures here. It creates our tables, but it doesn't actually create the files inside the paper directory. We have a little bit of duplication here because we started off our project manually copying and pasting into Overleaf. But we want to connect these together, so if we happen to change our analysis, the stuff on Overleaf updates automatically. So what we're going to do is add a new stage to the pipeline called map paths. And this is going to be a so-called map paths stage. So we'll put in kind is map-paths, and then inside the paths definition, we're going to map a few paths in there. So for each of these objects, we need to define the source. So let's say figures, and then we need to define the destination, dest. We'll put this into paper, figures, and then what kind of mapping is this? This is going to be a directory to directory merge. We'll do the same thing with tables. We're going to map that into paper/tables. If we jump back into looking at our status here, Calkit status, we're going to see that our new map path stage has never been run, so it's out of date. Let's just run the pipeline. and we see that our paper ended up automatically being rebuilt because paper/figures, paper/tables ended up changing. So everything is up to date now. And the nice thing about the pipeline is that you can just keep running it. And if nothing has changed, it just skips the things that have not changed. All right, again, we have a bunch of orange stuff over here. So we should do a save. Let's save the project, Calkit save, -A, -M, add map paths stage. All right, our project is saved. If we go back to the Calkit website and take a look at the pipeline, we can now see that our pipeline stages have some links between them. After we run the notebook, we're going to need to run the map path stage. And then after we map paths, if anything changed, we're going to need to rebuild the paper. So this all happens automatically. This is sort of the stuff that you would have been doing manually if this was not connected. If you had your notebook sitting on your local machine, you would have to manually keep track of, did I actually change a figure? Did my results really change? Do I have to upload stuff into Overleaf to build my paper? In this case, you don't need to think about that. And that is the main benefit here, is that you can just kind of do your work, figure out what works properly, and then just run the project to make sure everything is up to date. Let's sync with Overleaf again, just to be sure. And this is going to make sure that our figures and tables are exactly the same in both places. We can actually do this all in one step, syncing with Overleaf and running the project. Calkit run --overleaf or -O. It's going to sync with Overleaf before and after we run the pipeline. So we don't really even need to think about this sync process. All right, next thing we're going to do is, let's say we have some numerical results that were computed from our analysis. In this case, the notebook exported this JSON file, vif.json, into the results folder. So let's say we want to talk about these numbers in the paper. Maybe one of these is important to the conclusions, and we want to reference it directly so we're not copying and pasting, just in case we go back later and something changes about the analysis, and then we have to go in and keep track of where we had that number and make sure that we update it so we don't publish an incorrect result. We can do that with a different type of stage in the pipeline. We're going to use a JSON to LaTeX stage. We'll make a stage called results to tech. We'll use the stage kind JSON to LaTeX when we define the inputs. The first input should be our results JSON file, vif.json, and then outputs, paper, results.tech. We can also add some options in here for formatting. So let's say we want to do bill length millimeters, but we want to round it to 3 decimal places. We use Python string formatting syntax. We can reference the variable bill length millimeter and then 0.3f. You could actually add the units to this if you wanted to. You can add any text you want. In this case, we're just going to do the number. You can actually do some simple arithmetic with any of these values here, like if you wanted to divide, multiply, add, whatever, and you can do that in this block here. Let's go into our conclusions, and let's say we saw that the VIF result for bill length in millimeters was, and we want to reference our results. So we saw that this came out as results.tech. We're going to need to include that as input in the document so we can use that command. So we just do input results. We can reference it as results bill length millimeters. We can see that the bill length result has 3 decimal places, and it was updated directly from the results that we calculated. So no copy and paste required. Again, we have a bunch of orange stuff here, so we should probably run the project and save it to make sure everything is totally up to date. So let's just do Calkit, run, save, add results to tech stage. Go back to the Calkit website, refresh. Our pipeline now has this results to tech block in there. Take a look at our publication again, and we see that everything's up to date with our 4.656 number. We haven't synced to Overleaf yet, but we should do that. Calkit Overleaf sync. Go back to Overleaf and see that our results bill length millimeter is there. Compile on Overleaf 4.656. Now to tie this all together, let's imagine that we got to the end of our project, or we thought we were at the end of our project. We wrote up the paper, and then we realized, well, this result isn't significant enough or something like that. We need to collect some more data. Normally, this would be kind of a painful experience because you could imagine, all right, we need to go back and figure out when we change something earlier in the project, let's say our raw data, what else do we have to do to get everything back up to date, and how expensive is it, and how many times do we need to manually transfer data between different tools? In this case, we don't have to worry about that. So we go into the data set. Let's assume that we're going to sample some more penguins. We'll just add some rows to the data. In some cases, maybe you have a simulation that you're running to generate the raw data, in which case you could automate this part, just change your simulation. Say you need to run it for more time. Have your simulation run in the pipeline and change the parameters, and then you can run the whole project. But in this case, we're doing an experiment. So let's add a few more penguins, put a little bit of randomness in here. All right, so we can do Calkit status again. Okay, the penguins data has changed. We know that. We just modified that. We look at the pipeline status, and it's going to tell us our notebook is now out of date. What I'm actually going to do is run the entire thing end to end. We're going to run, we're going to sync with Overleaf. I'm going to imagine that we're not going to think about this at all. So before we do this, we'll see 4.656 for our results. Calkit run -- save. We'll put in a message, sample 3 more penguins, and we'll sync to Overleaf as part of running the pipeline with -O or -- Overleaf. So we see the notebooks running again as we expect. So the notebook runs, the paths get mapped, the results are converted to LaTeX, the PDF gets built, everything gets saved, and everything gets synced with Overleaf. Let's go look at our number. Oh, it's changed from 4.656 to 4.692. So everything is completely consistent in this project. Our analysis is consistent with the data set, the figures are consistent with the analysis, and the document is now consistent with the figures, tables, and results, both in our main project and on Overleaf. We can see again, build our Overleaf project. The result in our conclusion has also been updated. All right, so we're done. We've successfully connected the outputs of our analysis, our figures, tables, numerical results, with our writing up in Overleaf. Now we can work on our writing and analysis in the same tool, but we can still work on our writing in Overleaf if we want. If you want any help setting this up for your own project, I'll put some links in the video description. Thanks for watching and have fun.